This video is going to show several examples of how to find the domain and the range of a function. The domain is all of the x values that belong to the function, and the range is all of the y values that belong to the function. And they can be signified like this: domain of f, range of f. I'm going to show which x values belong to this linear function by projecting from the line to the axis. I can start anywhere, but I'm going to start here at x equals 4. Points on the line do project to the x-axis at 4. Also at 3.5, at 3, at 2, and at 1, at -1, -2, -3, etc. All values of x are projecting from this line to the x-axis. And because a straight line goes on forever in both directions, I know that larger values of x, like x equals 5, x equals 6, and so on, and smaller values of x, like x equals -5, x equals -6, and so on, are also going to project from the line to the axis. Therefore, all values of x belong to this line, and the domain of the function is R, all real numbers. To find the range of this function, I am going to project from the line to the y-axis. I can see that a value like y equals -2 projects onto the axis, y equals -1, y equals -0.5, as well as numbers like y equals +2, y equals +3, and so on. All values of y are also projecting from this line onto the y-axis. Therefore, the range of this function is also real numbers. Now let's look at this horizontal linear function. The domain I'm going to illustrate in the same way. The values of x that project from this line to the x-axis include -4, -3.5, -3, and so on. All values of x are projecting from the function to the axis. And this goes on forever in both directions, so therefore the domain of this function is R. All real numbers. The range is a little different this time. I can only find one value of y that projects from this line onto the y-axis, and that is y equals -2. It's the only value of y that happens in this function because it's a horizontal line, and therefore the range of this function is -2, which I express as a sec. Now we'll look at this third function. This is another linear function that has restrictions. The line does not continue below y equals -1 or to the left of x equals -3, and neither of those values are included because it is an open circle. The line does not continue to the right of x equals 1 or above y equals 4, but this time both of those values are included because we have a solid circle. To project from the line onto the axis with the x-axis, I can see that x equals -3 does not project, but x equals -2.7 projects, x equals -2 projects, x equals -1 projects. And in fact, all the numbers for x project from the line to the x-axis until we get to x equals 1, and then it stops. So the domain of this function is going to include all values of x in between -3 and 1, not including the -3, but including the 1. And I will express this with interval notation. From -3 to +1, the -3 not included, the positive 1 included. I show which values are included by making my square bracket point towards or away from the limit. We have our domain of the function. Now we want to show our range of the function. It works in a very similar way. From the line, I can project y equals negative 0.5 to the y-axis. And I can project y equals 1, y equals 2, y equals 3, y equals 4. I cannot project any y value higher than 4. I cannot project a y value of negative 1 or any value lower than that. So the range of this function is going to be from negative 1 to 4, with the negative 1 not included, so the square bracket faces away from it, and the 4 included, so the square bracket points towards the 4. This is how we can project from a line to the axis to help us figure out what the domain and the range are of a function.